In this lesson, we're going to look at indicators, and you'll need your data booklet open to page 10. An indicator is a chemical species that changes color in an acidic or basic environment. So it has at least two different colors depending on the pH of the solution that it's mixed with. Different indicators will change color at different pH levels. So there's actually quite a few indicators, and we're going to look at a few during this lesson. The first example we're going to look at that's on your table on page 10 is chlorophenol red. The indicator name is given in the far left-hand column, and then in the second column that's labeled as suggested abbreviations, there are lots of formulas there that look sort of like element symbols. If you find chlorophenol red, right in about the middle of your page, in the second column you'll see those two abbreviations. The first one that's given, HCH, is the acidic portion or the acidic form of that indicator. So if chlorophenol red is put into an acid solution, it will have the formula HCH. Now the CH is just an abbreviation for a complex large molecule that you don't need to know the formula of. If you put chlorophenol red into a basic solution, then it will have the formula or the form CH minus. So in its basic form, it no longer has that hydrogen, H plus, bonded to the rest of the molecule. In the third column, you'll see the pH range, so the pH values where we would see the change in color for this compound. So the first number that it gives you, 5.2, is the lower level, and the 6.8, the second number, is the upper level. The colors that are in the next column are the colors that are associated with those pH values. So at a pH of 5.2 and lower, chlorophenol red looks yellow. But at a pH of 6.8 or higher, chlorophenol red is going to look red. So below pH of 5.2, chlorophenol red looks yellow. And in a solution that is pH of greater than 6.8, chlorophenol red will look red. Between those two pH values, so say you had a solution that was a pH of 5.8, the indicator is going to be a combination of those two colors, yellow and red, so it's going to look orange. Not all indicators have a color that will, the two colors that will allow you an in-between, only some of the ones on this table. You need to be able to determine the color of an indicator if you're given the indicator and the pH of the solution that it's put into. So phenol red, another indicator on your table, if we put this into a solution that had a pH of 9.2, you'll see that the range that's given there is 6.6 to 8.0. The 9.2 pH value is above the upper limit of 8.0. So for anything 8.0 and higher, look to the second color, so red. So chlorophenol red in a solution of pH 9.2 will look red. Second example, orange 4. Go back up on your table. This time we have a pH of 1.9. The range for orange 4 is between 1.4 and 2.8, and the pH of 1.9 falls right in between that. So between the red and the yellow, this compound is going to look orange. Third example, cresol red. Go a little bit higher on your table. We have a solution of 11.4. Cresol red is one that has two different pH ranges. So it can change from red to yellow at a very low pH between 0 and 1. And it also has a second change from yellow back to red when it changes from 7 to 8.8. So if our solution is pH of 11.4, that's above the upper limit for the second change. So this solution is going to look red when we add in the cresol red indicator. For question D, look very carefully at the information that you've been given. Bromothymol blue in a solution of POH 3.2. The table that you have in your data booklet is for the pH ranges. we have the pOH of a solution. So the first thing we need to do is figure out the pH, and that means that we need to subtract from 14. So 14 minus 3.2 is going to give us 10.8. For the pH of 10.8, now we want to look at bromothymol blue and see where that falls. So bromothymol blue changes between 6.0 and 7.6 from yellow to blue. pH of 10.8 is well above that upper limit. So this solution would look blue if we add in bromothymol blue. You should also be able to do the reverse. If you're given different colors of indicators, you should be able to determine the pH or the pH range of that solution. So here's two examples where you have 3 different indicators and their colors, and you're going to figure out the pH of the solution. So first one, thymol blue, is yellow. So if thymol blue is yellow, that means that the pH is going to be between 2.8 and 8.0. That's our upper and lower limit based on thymol blue. Next, for methyl orange is yellow, and from the table, yellow for methyl orange means that it's above 4.4. So 4.4 now becomes the lower limit, and we keep the upper limit of 8.0 from the last part. For chlorophenol red is a red color, so this means that pH has to be above 6.8. So 6.8 is our lower limit. We still have an upper limit of 8.0 from the previous indicators. So for this solution, the pH must be between 6.8 and 8.0. For the second example, we have phenol red that's red, indigo carmine that's blue, and thymolphthalein that's colorless. So starting with the phenol red that is red, our lower limit is 8.0 because phenol red is only red above 8.0. So we must be 8.0 and higher. Indigo carmine is blue. So when you find indigo carmine and look for the blue color, that's the lower color on the table. So that means that it must be 11.4, the lower limit, and below. So at this point, we know that we're between 8.0 and 11.4. The last indicator, thymolphthalein, is colorless. So for the colorless, which is the first color in the table, that matches with a pH of 9.4 or below. So we have a solution that's less than a pH of 9.4. And from looking back at the phenol red, we can see that it must be above 8.0. So our pH for this solution is between 8.0 and 9.4.